I'm Cale.
I'm Jim.
And I'm Steven.
And we're Team Relatively Relativistic, and we're affiliated with
the Governor School for Science and Technology.
Jet engines produce harmful air pollution in the form of carbon dioxide, which is hazardous to the environment and is a notable greenhouse gas. Jet engines also create lots of noise pollution, which prevents jets from flying at low altitudes without disturbing the public. With the rising cost of jet fuel, airlines could save billions of dollars a year by switching to a non-liquid fuel-dependent system, such as our Electrohydrodynamic or EHD thruster. Our EHD thruster will create less noise than a traditional jet engine, as it lacks a combustion system. A jet engine can cause parts of the plane to resonate at the same frequency, increasing noise for both people on the ground and in the plane. With our EHD thruster, no noise cancellation is necessary. The EHD thruster's only pollutant is ozone, which is harmless to the environment at traditional flight altitudes. The ozone produced can also reduce the size of the hole of the ozone in the stratosphere.
Our design features a front scoop, which will funnel the air towards the positive coronal grid. The rear of the thruster will have a negatively charged collector grid, which the ions produced at the positive grid will move towards. The air reaching the grid will be at a much higher pressure, which increases the amount of ions the grid can produce, as there are more available particles to ionize. The side plates of the scoop will have a separate voltage control, which would allow for a pilot to increase thrust beyond what the two grids can provide. At lower speeds, the side plates may reduce thrust by pushing some ions out of the front of the thruster, but at higher speeds, the air pressure should be enough to ensure the ions are funneled out the back. The main part of the EHD thruster that would require maintenance is the coronal grid or electrodes. The high electric field stresses, combined with the high temperatures that occur during operation, will cause ablation over time. The benefit of solid-state parts would greatly reduce maintenance costs, and the relatively simple design would make manufacturing easier and cheaper than in standard jet engines.
For the power supply, batteries can be charged using renewable or nuclear power, reducing the impact on the environment. The battery voltages can be transformed by using an inverter to create an AC current, and then running that current through a transformer of a suitable winding ratio. In order to get the DC electrical power needed for the thruster, the output of the transformer can be put through a full-bridge rectifier. In order to make sure the electric field stays relatively constant in the thruster, a capacitor can be added in parallel to the thruster to help smooth out voltage fluctuations. Controlling the voltages would be done by having a high voltage potentiometer in series with the output of the full-bridge rectifier and thruster. This method seems less complicated than solutions for regulating voltage in front of the transformer portion of the power supply. To make a concept into reality, we plan on marketing our EHD thruster design to airplane manufacturers, such as Lockheed Martin and Boeing, to whom we would license our patent. Manufacturers would initially use the thruster to power smaller airplanes, such as ultralight aircraft. Over time, we would collaborate with the manufacturers to scale up our design for use in larger commercial airplanes. We hope to obtain funding from sources such as government research grants and private sponsorships.
We have created many different renderings of potential EHD thruster concepts, such as a ramjet and an airplane. We are currently working on a small-scale prototype of our EHD thruster. We initially started with a shoebox with corona wire made out of nails and an electrode made out of copper tubing. We placed a piece of tissue behind the thruster to observe the deflection from the thrust. To create a larger-scale thruster, we laser cut a box out of acrylic to protect the thruster from any outside elements, such as debris from the air conditioning. If we were to obtain funding to create a full-scale prototype, we would invest in manufacturing our own high-voltage power supply, along with machining a scaled-up version of our ramjet.